Hello everyone. Thank you for joining us for the second webinar of IT Career Fundamentals, a short course presented by IT Masters on behalf of Charles Sturt University. My name is Guy Coward, course coordinator and MC for the course webinars. Your expert on cloud computing is Tim Jones, who teaches many of the subjects in the Charles Sturt University cloud computing and virtualization degrees. We'll hear from him shortly. Before we welcome Tim though, just the usual housekeeping. Using Zoom for our webinars, we encourage questions and the use of chat throughout the course. We ask that you direct all questions relevant to the course content, what Tim's talking about tonight, to the Q&A section, and that you send all administration type questions about, dates, times, resource availabilities, those sorts of things to Hannah in chat. As we're constantly saying, you can chat with panelists only, or you can include all of your fellow students as well once you open the chat log. Tonight we'll have a longer Q&A session at the end of the webinar, but if there's any particularly relevant questions, I'll interrupt Tim. We'll get into it. Hannah's here as admin and technical support. She's looking after you all in the chat, and we're ever grateful for that. She's also responsible for the learn.itmasters.edu.au website, which is where you'll find the other course materials you need. Readings, discussion forum, prompts and quizzes and those sorts of things. We're adding to it all the time. It's a bit of a love job, so I'm just patching it together as we go. So check back in every few days and see what's new. Hannah, wondering if you could please also add a link to the course in the chat now. It's time to introduce Tim. He's a self-confessed technology evangelist, which I think explains the teaching on top of his impressive industry history. As I was saying, I've never had the pleasure of working on a short course with you, Tim. So if you can be bothered after the last week of running around after me, I'd love to hear any cool ideas you have about free cloud or virtualization courses we should run. And I suppose that goes for all of you listening along too. If you have any topics you'd be interested in, that'd be sick. But yes, anyway, digressions aside, thanks for joining us, Tim. Welcome. Please make him welcome in the chat, folks.
Thank you. Wonderful. It's great to have everyone along for an evening. So as we went through, I believe last week, this is a nominal 1 hour time slot, but that's
nominal at best.
Yes, yeah, nominal is the indicative word. So we're happy to go longer. So if you've got questions or things that you want to bring up, come through with the Q&A area, and more than happy to expand on any of the areas that are of particular interest. And we'll also have the Q&A session at the end there for covering any questions people have from an education, industry, certification, or career type perspective, or anything like that. Or even if you want to know what the weather's like, but happy to work with you around any questions that you have, and this is as valuable as the people that are adding to it. So please be involved and listen in. So much appreciated with you all coming along for this. So just to start with as well, I've seen where a whole heap of people from, and I'm from Melbourne, so we're enjoying a maskless foray into the outside world at the moment, and I see there's a whole bunch of other Melbourneites here as well. So to get into what we're looking at tonight. So first of all, we'll delve into just a little bit of background. I won't spend a lot of time on me. I'm sure it's fascinating to a very small percentage of the audience, but I won't spend a heap of time on it. I'll go into a definition of cloud. We won't come to an absolutely firm definition because by its very nature, it's amorphous and we don't know exactly where it starts or finishes. But we'll set a definition for the conversation that we're having today and for the conversations and settings that we're looking at for the work that we're running through. I'll run through a brief history of cloud, both in the context of the definition that we've worked through, but also from a broader computing stance. So where have we come from? Why is it important? What are we doing with it? A view of state of the nation, of like where we are right now, of what things are happening with cloud, what's pushing the marketplace adoption and decision-making that's happening within the space. We'll go into some architecture in that, and once I go through the about me bit, it'll make it more understandable why the architecture is important to me as part of my work and career, etc. I'll run through a short demo around cloud solutions, containers, how they operate, and what you can expect from working with both cloud and container environments and why they're important. We'll then finish off with a brief view of future of cloud. So very much a finger in the air view of what potentially is coming up in the future, what we can expect from cloud technology, what we might want to continue to learn or understand, etc., from the cloud technology perspective, and finalize with a discussion. So, to launch into it. First of all, about me. From a personal perspective, as I mentioned, I'm a Melbourneite. I live sort of in a city, and as you can see with the picture with me with a dog on my back, it's sort of older hipster territory. I'm sort of in a Melbourne suburbanite. I've been in IT for a very long time. So I started IT when I was relatively young. I've been doing it for 30 odd years or something like that now. But last 20 years, I've been working as an architect, and last 5 years of that have been quite specifically in the cloud space. So from a professional standpoint, at least. From an education side of things, I did my IT Masters back in 2008, specializing in security. And that was an important educational milestone for me. It was useful to have from a CV perspective. It was useful to have from the perspective of the type of work that I was doing as an architect at the time. It was also useful from a career progression perspective. I came from a background of having done a lot of certification. So I did my MCSC, I did a whole bunch of other certifications as well, but I hadn't completed any tertiary qualification up until that point. I'd started and stopped a few times, but the opportunity to move into a master's course based off the industry experience that I already had, and to couple that with my background in certification and workspace, etc., was valuable. And it gave me, as I said, a lot of value from a professional and personal perspective, but also that career progression view of, yes, I've ticked a box for having a tertiary qualification which is seen as valuable in the industry. From there, I became a subject mentor since 2018. So my personal view is, as I'm sort of realize, or at least my girlfriend tells me, I'm starting to tick on in the years, I'm starting to have a view of what a potential semi-retirement looks like in the future. And working in education is something that interests me. In the past, I've been a Microsoft certified instructor. I've worked in education in the organizations that I work in. I currently have an educational part of the role for the business that I work with at the moment. And so working as a subject mentor in an educational standpoint for tertiary education has been very interesting. It's been rewarding, entertaining, and interesting dealing with students on a day-to-day basis. So it's certainly been a large boon to me, the opportunity to work with IT Masters and to expand upon what I do from a day-to-day career into how I work with students and help other people sort of reach their career, personal, financial, educational goals. I'm also a certified cloud architect. So I've got the professional certification for architecture across the major 3 platforms. I also have a very long page of industry certifications as well. And so for me, this is an important part of a technical based career. As I mentioned, I've been in the career path from a technical side for a very long time. And if you don't move into project management, and if you don't move into person management and want to stay in a technical role, a really big requirement is to continue to educate yourself, to work with education with others. And it's something that I very much espouse for anyone looking for an ongoing, in particular, technical career within the IT space. If you're not learning, you're drowning, all right? So your skills will quickly become out of date. But for those of us like myself, learning is something which is part of the core of who I am. It's something that I enjoy as far as a goal setting standpoint and as far as an ability to expand what I'm doing and make available. The things that I don't enjoy about it is when you get down to exam time and you're really worried whether you've passed the exam or not. But once you actually get the little green button on the screen that says that you've passed, it's much more entertaining, at least from a certification standpoint. Okay, so just one final thing. Happy to connect with anyone on LinkedIn. So the connection that you'll find me on, if you just go to Tallman Tim on LinkedIn, as far as the shortened icons, happy to connect up with anyone. But from a work perspective, I work with Dell Technologies as a global enterprise architect. So that just means that I work on very large customers and how they look to transform their IT infrastructure. And generally speaking, that's transforming to some form of cloud. All right, so that's the enabling technology, but we'll go through that in a sec. So what we're looking at now from a definition perspective. So iCloud, YouTube, Dropbox, these are all cloud technologies. If you use your mobile phone, you use probably 30 other cloud-based technologies as well. So there's lots of things that people know and expect from a cloud perspective that make sense to them, but these are all consumer-based things. So anyone's personal files, so I have copies of particular documents that are saved up to Google Drive. I also have like a Dropbox account. I have a OneDrive account from Microsoft. I've probably got a whole bunch of other storage accounts elsewhere for caching information. But what we're looking at tonight is more in particular the enterprise cloud. All right, so looking at large-scale businesses and what they do from a cloud perspective, rather than necessarily a client or consumer-facing view of cloud. But if you're looking at enterprise cloud, again, what does that mean? All right, so it's again amorphous. We don't know exactly where the cloud starts and stops. All right, so by its very nature of using the word cloud, it's not clear of the surface, the interface points, etc., of what's cloud and what's not. So co-location, if we just have some servers sitting in another organization's data center, is that cloud? For some people, it will be. Right? Again, if we look at managed services and outsourcing, right, there's components of that which are very much cloud-like, that we can have integration points or calls or connections to external organizations that give us the capability to map and manage those resources that we use from an organizational standpoint and make them available to a larger audience. So managed services and outsourcing can also be potentially a cloud-based component. Private cloud, right? So this is again is looking at having your own data center and enabling it with technologies such as the latest version of VMware, which is part of the organization that I work with, or OpenShift, which is Red Hat-based technology for deploying infrastructure-based cloud solutions and container-based solutions, etc., that we can run in our own data center. And is that cloud? Well, again, yes. So all of these things make up what can be cloud from an enterprise standpoint. And finally, we have the infrastructure as a service, platform as a service, container as a service, software as a service, X as a service. So anything else that we like as a service. So business processes as a service. We can map any function to a service-based delivery and functionality that we provide to our corporate clients as a provider or consume as an organization. More generally, what we're looking at in the modern view of cloud-based infrastructure, application deployment and management is a move towards API-centric infrastructure. So what we mean by API, application programming interface, that we have well-known methods for accessing information, and also if we access all of our resources and assets within our data centers across our own data center, within the cloud organizations such as AWS, etc. All of those methods of accessing, if they're API-based, can then be digital assets for configuration, control, etc. We'll go into that in a little bit more detail in a few minutes. So what does that mean then from our definition that we're looking at for cloud? So I've mentioned all of these things. I've said all of them are cloud. What are we looking at from the perspective of today's discussion for cloud? And with that, the view that I have for this discussion is where we're running applications that you would normally have in a data center somewhere going back 10, 15, 20 years or something like that. The type of applications that large enterprises run sitting inside a data center that are now located elsewhere or utilizing modern capabilities. So again, if you're utilizing infrastructure as a service through AWS, or you're using platform as a service for SQL Server through Azure, or you're using container as a service through Google Cloud, or you've got an API interface to deploy your infrastructure, your VMs, your containers. You've potentially got serverless code running within your own data center, and you've got continuous integration and continuous deployment available within your own data center. All of that is cloud. So what the main components that we're looking at is it's either not in your data center or we're using modern capabilities or both. So when we're looking at these cloud models, just as an aside, one of the things for the notes where I have pulled information from other areas, you'll see a note down the bottom of the screen. So because we're an academic organization, things like referencing then become really important. So a big note around referencing is if you put something in without referencing, right, so without attribution, then it's plagiarism, right? So if I didn't have that link from an academic standpoint down the bottom of telling you where I got the information and saying that I'm acknowledging where it's got, it'd be a form of plagiarism, pulling that away, and that's a big no-no in an academic circle. However, if you reference something from another organization, another paper, a research point of view or something like that, that's then a massive boon. So there's a fine line between being a rock star researcher and a plagiarist. Right? So keep that in mind from an academic career perspective, that there's a very small gap between a cheat and a plagiarist and an excellent researcher. All right, so I'm trying to put myself into the researcher side of the fence. Right? So on the notes where I've not created the content myself, you'll see a note down the bottom of the screen. Now, what we're looking at here is the basically the progression of application and system capability through time. So in the bottom left-hand corner, we've got dedicated IT. So this is our traditional IT, our legacy IT, whatever you want to call it. Our existing data center that is a whole bunch of servers, a whole bunch of data center space, some floor tiles, some cooling, networking, storage, etc. Right? We've got applications loaded on the infrastructure on top of that, and we've got investments and capital tied up in it. Now, there's a progression from there to move to cloud environments. Right? So this is where we start moving into the DevOps space, where we start to move into, where I was mentioning before, infrastructure as code, the ability to automate capability, to also have capacity management taken out of your hand, because you can consume as much as you need, as much as you want, when you want. Right? But it's pay per use. So it's a utility model of computing rather than a capital expenditure view of computing. Now, some organizations will find a capital rich and OpEx poor, in which case they may prefer to have their own data centers in an ongoing basis, purely from a financial perspective. But most organizations like to be able to see month by month costs. They don't like the lumpy nature of having to refresh hardware and software every few years and having $20 million bills that come once every 3 to 5 years, rather than having an ongoing cost that can be much better managed, budgeted for, and put into the spreadsheets, etc., for how the bean counters deal with it. Now, in the top right-hand corner, we also have the application side. So with this, in a traditional sense, on a traditional data center where we'd install all of our applications within our own data center, on our own equipment, and make it available to our end users, etc. So the move that we have now from both these cloud environments that we migrated our data center systems from, and from the application environments, is to view more of an as a service delivery. So one of the primary views that a lot of organizations have as far as deployment of new applications, or looking at refactoring applications, is to have software as a service as the first port of call. If you can have another organization own, manage, and deploy all of the required software, updates, capability, capacity, etc., in their own organization, and you consume it on a per user basis or something different, it becomes super easy. You don't need to plan for your own infrastructure. You don't need to have your own application staff. You definitely don't need to have your own very expensive cloud skilled staff to manage how the application operates in a cloud environment. But that's the view of how things are moving from the cloud platform as well. So cloud platforms are making tools available, functions available for both corporations and for software developers to make as a service-based application deployments, and to integrate a lot more of those modern software development and deployment capabilities into the platforms that they use. So again, looking at those things like continuous integration and continuous deployment to keep things up to date and rapidly moving and flexible from an application availability perspective. Now, the other side from what we're looking at cloud is where we're at in the cloud lifecycle. So a lot of organizations that I deal with are not even really on this map. So zero starts at a level which many organizations haven't actually met yet. So when we look at zero, we're saying that we have mostly virtualized infrastructure, and we use scripting, for example, for deploying applications, infrastructure, etc. Right? The cloud-friendly view is that we have services available, we have discoverability, we've got a lot more intelligence based in and based upon well-known cloud patterns and how we deploy applications. We then move to cloud resilient, and the state is then based upon what we're doing from a service perspective. Right? If we have failures at any one particular point, we're self-healing, able to route around any problems or deal through high availability with anything that would come across. Right? So we have the architecture, design, infrastructure, capabilities within the applications so that we're not reliant upon any one data center with any one link coming into the organization. We're able to deal with any outage that may come through. Right. And finally, for the level 2, we're also infrastructure agnostic. We don't care where the application's running. Right. So one of the big pushes that we're seeing at the moment, for example, with AWS, is they're moving towards ARM chips as a cheaper cloud deployment model for things like web servers, because you can get a much higher processor load and capability from ARM chips with an incredibly low power footprint. And so they make perfect sense for a whole bunch of applications. So why wouldn't we have part of our infrastructure running on cheaper, more available, more capable systems? And then finally, when we move to cloud native, right? So this is the nirvana for a lot of application managers, especially those that are currently running legacy monolithic applications. They would like to get to cloud native, right? Because it comes with a whole bunch of advantages. We end up with platforms that are transferable across infrastructure and cloud providers. So with a touch of a button, we can move an application from one location to another, and we can also share the application across multiple cloud providers as well. And we also scale out or scale in based upon what's happening with the application. So that's where we're looking at from the perspective of the maturity of an organization and how they're consuming their cloud-based assets, etc. Which then brings us to...
Before we go on, sorry, onto that poll, we've got a bunch of chat action and question about instantiatable. Please help, not academic.
So where was that?
Instantiatable from image or script.
Yeah, instantiatable means basically being able to be started.
Beauty. Thank you. Hope that helps. Anonymous attendee.
Excellent.
And we've got a poll.
Yes, a poll.
I'll launch that now. and it's what is your organization, whether it's a business, school, or other, cloud maturity level. Speaking about the modern components. So you should be able to see.
I haven't worked with one of these before. So
yeah, they're good. This is the difference between a webinar and a meeting. So for the classes that we have in our paid subjects, folks, you all have your mics turned on and those sorts of things and have a chat. But with the webinars, we have the power and we also have a couple of extra functions.
Yeah, this is like a horse race.
Yeah, and cloud friendly coming off on the inside. Cloud friendly for most people, or for is chip leader, about close to 30%, and then none of the above. Cloud resilient, decent chunk.
Excellent.
Beauty. So we got about 55%
that's
of
good
people.
To see. No, it's very interesting because it's it gives a good snapshot of where things are at within organisations. Because what I see from my day-to-day work is that there are pockets of quite advanced components. So I've worked previously for a few banks and they had various components that were full container-ridden applications with the proper CI/CD pipeline and capabilities to rapidly deploy updates, etc. At the same time, the same bank had a Windows 95 machine that was virtualized in Windows 2000, that was then virtualized in Windows 2012, and then sitting on top of VMware from a management standpoint because no one could work out how the original application worked and get it working. That from the bank perspective, that application was the complaints system. So there also wasn't a big push to really spend a lot of money on the complaints environment for the bank. This is also before the Banking Royal Commission, so now that might have now changed.
He's hoping we care at whichever bank this is. Exactly. All right, so we got 70% of people voted. Yeah,
nice one. Yeah, that's really good to see.
So I'll share that to all of you folks looking along, and you can have a look there.
We've got a winner.
Cloud friendly. So some work to be done. Some work to be done.
That's great. All right. So now into the history of cloud. Oops. Sorry, just leant on my keyboard. Yeah. It's what happens when you talk with your hands, even if people can't see them. Yeah. So what we have with the history of cloud, just like we had with the definition of cloud, it really depends upon your definition of what cloud is as to what the history looks like. So time-sharing computers were available back in the 1960s. So IBM 360-based systems and other bits and pieces were available for a very long time, right? So 60s based. We even had companies start up with doing time-sharing time on computers sitting back in the 1960s as well. So had computers that you would use a dial-up network. I think it was like 30 baud or something like that. So you'd end up getting 30 characters per second coming back from any updates you did on the screen, and you'd be paying for that based upon the time that you used, your CPU cycles, and any storage that you utilized. Again, that's in kilobytes. So you'd be spending a lot of money for utilizing those compute resources. But again, those computers were hugely expensive themselves. So sharing them certainly made sense. We had co-location hosting and managed services expand since the 1960s as well, though. So the ability to host your applications on someone else's hardware, right? Whether that's an IBM mainframe or a Unix system, or moving into the 1980s, an IBM-based PC type setup. But what we're looking at when we talk about modern cloud, it's more talking about the hyperscalers, the cloud service providers that have really changed the landscape of what's happening across the entire corporate and enterprise IT industry. So we had Amazon launched with S3, SQS, and EC2 in 2006. We had Google Cloud Platform release in 2008, which I found quite interesting looking through this information, because Google Cloud Platform hasn't really been something of a mainstream cloud provider from a corporate enterprise perspective up into the last few years. So the fact that they launched soon afterwards, I found quite interesting. And then Microsoft Azure released in 2010, and they've certainly been doing more inroads against both AWS and Google Cloud since that time, and have cemented themselves in very much the second spot in those three large hyperscalers. So from a history perspective, again, we're jumping into a quick view from another quiz. All right, so just interested to know some history around the people who are on board. So Guy, have we got another quiz ready to go?
We certainly do, as
Awesome.
I fumble around with my mouse.
Don't lean on your keyboard.
When did you first get involved with cloud technologies in some way?
Yeah, I've hard to say whether I'm number one or number two. Yeah, probably always part of my professional life. I worked as a barman and a builder's labourer before I worked as a IT person, but that's not really my professional life as a barman.
Depends how good you were, I guess. What any bars of renown?
No, I worked in a rough public bar. So you'll certainly learn how to deal with interesting people when you work. So that was Matthew Flinders in Chadstone. It's now a pokies venue.
Oh,
yeah. Back in the day, it was the local football club would come through every Saturday. And
heavens.
I remember my parents turning up the one and only time to the pub, and there was a Bucks night that came through at the same time as the other people were there, and we ended up having to split up and all in brawl. So
wow. That's all bloody exciting. Matthew Flinders is just around the corner from me, so there you go. Anyway, most people about 2 to 7 years ago, so about 40%.
Awesome.
Then we've got a fairly even split, somewhere between 10 and 20 for the rest of them. Quite interesting. I guess in years to come, that's going to shift heavily towards it's been around forever.
Yeah, well, it's also the nature of the game, because as I was mentioning earlier around the need, if you're a technical person and you continue to work in a technical arena, you either stay in exactly the same job until it becomes obsolete, which I've seen plenty of people do that. People who operate as a program in a particular area, or administrators for something, and then they haven't upskilled. They keep a job, it doesn't change, and then they don't have a job anymore. The other side is people who move out of the technical side of IT. So there's a constant churn within IT of the fresh-faced youth, which I most certainly am not. But so we have new people coming through. It's the learning curve is high. The interest to continue to learn continues to be high for people in particular coming in new to the environment. But we see some of those people move out to management or project management or business-based roles, either because it's a promotion, it's more money, more capability, or for some people that I've worked with, just the capability that they no longer need to run the treadmill of continually learning and keeping up. Because again, one of the problems that we have within the IT space is that the needs to learn and understand what's changing in the IT space from an application, infrastructure, cloud, etc., is accelerating. As with all technology, the need to stay up to date is changing super quickly.
I guess that sort of I hate using this word, but dovetails well with the intention of this course, right? Like it's, you know, part of the reason for this course being around is, you know, just the rapidity of change in the labour market generally. So a lot of people are trying to get into IT but don't have much experience. So we're trying to, I guess, let people skip a few steps and get straight into that fresh-faced phase.
Absolutely.
Yeah. Alrighty, so we've got 40% 2 to 7 years, and the rest are relatively small. Thanks.
Cool. All right, so this is a bit of a eye chart for everyone. What we're looking at here is the technology view of what's being utilized in the computing type space. So from a cloud perspective. So what this means is these are technologies which are really quite current. So microservices, so we'll talk about that a little bit further later on, but the ability to break down applications into small manageable chunks, whether that's looking at refactoring an application, which is I'm dealing with one of my large clients at the moment, where they're taking large applications and they're essentially rewriting them from scratch in a microservices framework, or whether you're taking that, you're creating a brand new application, or the other side of it is the ability to what I term as evaporating a legacy application, taking small chunks of the application one bit at a time and converting that very small API functionality into a microservice and then removing that from the larger legacy platform. Now, that's very much dependent upon the capabilities of the legacy type system, but all of these are ways that you can move away from, in part, these big iron applications. So when we're talking about big iron, legacy, large scale infrastructure applications sitting in data centers, we're talking about things like SAP. Right? So a large scale enterprise planning platform, which requires heaps of internal programmers, support people, management people, but also from an infrastructure standpoint, they're very hard to deal with on a day-to-day basis. They need to be nursemaided to keep running regularly, and any change that happens to the system requires a lot of testing and needs to happen across the board all at once. So you only end up having changes happen once every 6 months or a year or something like that. I know that the change window for one of the banks I was working in was 18 months before you could get to the point of making any change on their mainframe system. So they were looking at interfacing systems through microservices and capabilities on how you enact change within that system without actually changing it. We've of course got DevOps, basically the ability to manage our operations tasks through scripts, through code, through API, and having digital assets to manage all of that. Cloud modeling languages, basically the ability to map out how our code operates or our infrastructure operates on a code-based level. So Helm scripts, the ability to map out and manage those components for disaster recovery, for high availability, for load balancing, for scale up, scale down, etc. Standardized deployment units. Right? So this is something, because a part of my role on a day-to-day basis is being part of working with the sales organization. And so one of the things that we see all the time with how we sell components that we deal with to end user clients and how they're used to consuming them from the hyperscalers such as AWS is through utilization of t-shirt sizes. So you have a small, medium and large, you have a small with GPU, you have a large with extra memory, you have some fast disk on one, etc. But you've got a standardized consumption model for how you utilize those components and makes it easy to map out rather than having everything bespoke every time. Elastic platforms, right? The ability to scale up, scale down. If you're in the middle of the night and you've only got Australian clients, you probably only need a couple of web servers for your e-commerce site. But as we move into Black Tuesday, I think it is now, the sales side. Is that right, Guy? The Black Tuesday, is that?
I've got no idea. It'll be in the
Black
chat.
Tuesday,
Sure.
Black Friday.
Black Friday. We got Cyber Monday. We got Black Friday.
Yeah, exactly. One of those. It's like Halloween in Australia. Like we much attention, but we get some stuff happening anyway.
As Tim says, buy stuff days.
Yeah, exactly. So we have those sort of days come through from an e-commerce site, and as more users come online, you don't want to have your e-commerce site fail. You want to scale up as required. Serverless, so this is technology which is very much coming to the fore at the moment. The ability to write code that doesn't need to have a request engine sitting there on a virtual machine, on a container, or anything else. It's completely API driven, right? So of course you've still got a server sitting behind there somewhere. Someone's running computers somewhere, right? So you don't get away from computers or anything like that in totality. It's not magic, right? But it means that the patterns that you deploy applications with can be much more flexible, can be cheaper, and easier to manage for you, even if it's quite complicated in the back end. State isolation, right? So knowing that if we make a change to one part of the application, again, looking at things like microservices where we separate out the API components of applications, that we're not going to cause any problems with anything else across the board. Version REST APIs. So again, looking at that API view and how we deploy things, and loose coupling. So the expectation is how we have applications working with each other, and that we're not reliant upon each stage, that we just expect that we'll be able to send information somewhere and get a response. So that's the view of where we're looking at with technologies being taken up right at the moment. But the flip side of that is looking at, so there's some problems with some of the deployments that I see customers making in a deployment framework from a cloud perspective. Right. So we see some clients moving workloads to the cloud as is. All right. So I've sort of outlined this at the top. So problem patterns and exec KPIs. All right. So one of the things that I see for some large organizations is they will get in a new CIO or something like that. They've got a requirement to modernize their platforms, to be seen to be doing something for modernization. And one of the most visible ways of modernizing what you're doing from an infrastructure and application perspective is to move stuff to the cloud. Now, the really easy thing that you can do if you're moving stuff to the cloud is just to take whatever mess that you've got there at the moment, pick it up as it is, move it to the cloud, do the work that you require to get it up and running in the cloud, but you've still got the same mess that you started with, but it's now just in the cloud, right? So you're running into some potential problems because you haven't fixed the problems that you already had. You're probably costing yourself more because you haven't refactored anything to actually take advantage of how the cloud operates. You probably have to overblow the t-shirt sizes of the application servers that you're running in there. And often what we see as well is people don't take into account all of the ancillary costs that come with moving an application to the cloud. So that includes making sure that you've got fast disk sitting underneath, right? So the ability to have enough storage that's running fast enough, the ability to have DR copies of both the data and a hot spare of the application server. The ability to make sure that you back up all of that data and that you're able to recover from it in an ongoing basis. Right? And importantly, the ability to have all of your dev and test environments up and running and being copies of the master. Now, one thing that makes it really easy from a cloud perspective is to clone those production systems or have them up and running and make them available. But what that means, as we see in the second point here, is the flexibility of deployment can mean that if developers are given carte blanche to spin up new virtual machines, etc., they can end up just spinning up as many. They might spin up 2 environments, they might spin up 10 environments because they've got a bunch of use cases they want to test through, and they might not shut them down afterwards. So we see customers that have an expectation when they're doing a cloud migration journey that they're going to be spending $250,000 per month. And we see within a 6-month time frame that moves to $500,000 per month because of these ancillary changes, the lack of refactoring of applications, and changes required to actually take advantage of the very clever systems that are sitting in the hyperscalers and those cloud platforms. The other side of it as well is when we see modern applications get deployed, this isn't a problem right at the moment we're seeing because we're at the pointy end of deployment of applications, right? Where people are using containers, they're using serverless, they're using modern capabilities to deploy systems. And as part of these new deployments, they've got gun programmers in, they've got the best DevOps staff, and they've got it all running along tickety-boo. Everything's working perfectly while they've got all of the gun staff in place. One of the things that we see some organizations do is they don't plan for when they no longer have the gun staff in place. They don't put in place the smart back-end capabilities to manage these applications for when they're no longer cutting edge and they become legacy. Because everything that we're putting in place at the moment eventually will be a legacy application that is managed by someone who does the equivalent of clocking in at 9, clocking out at 5, is only marginally interested in what they're doing on a day-to-day basis, and is not part of what you would term as the gun team. Right. So those environments that are put in place really need to have that in view of what happens with the environment once it's a legacy one. And this is just a view as well of one of the things that, again, see with those KPI views is if you just pick up all of the stuff that you've got sitting in your own data center and or your metaphorical basement, and you move it from your basement to Jeff Bezos's basement, then you're no better off other than you're no longer having to deal with the data center components. Right? So the data center is really expensive. It's hard to manage. You require a whole bunch of specialized people, but even just moving VMs and other capabilities to the cloud requires a whole bunch of other expensive staff and capabilities. And you've then got expensive ongoing monthly bills as well. So one of my key takeaways from this is don't just chuck stuff into Jeff Bezos's basement. Look at other ways of managing, deploying, and making available cloud-based assets, whether they're in your own data center, someone else's, but that whatever you do to change applications, to change infrastructure, to make things available, pushes things into a better path, right? Even if it's just a nudge, right? To make things more manageable, to look at who's coming along behind you, right? All right, now looking at the architecture for cloud solutions. So we'll have a look at the client side, the application side, and then the infrastructure side. So from the application side, so looking at clients, users, devices, there's a requirement these days to build things out at web scale. Right? So what web scale means is the ability to have millions of users potentially hit our site almost immediately. If we create an application like TikTok, right, that became suddenly very popular, or maybe it wasn't suddenly, I might just be way out of the loop and it's been around for years, but from my perspective, it was quite suddenly it became very popular, that we need to have systems and capabilities in place to scale up with the number of users and expectations that are coming through with them. So we saw that with Dropbox and Netflix were built on the AWS platform, right? So Dropbox was one of the first major S3 clients. They built an entire business around reselling storage from AWS. Netflix similarly had their application and storage functions sitting within the AWS space, and it allowed them to grow quite rapidly, massively as well. Both of the organizations have reached a point where it makes sense for them to have their own private data centers and capabilities for how they deploy these things now. From a cost and capability perspective, they're no longer locked into the ways that AWS manages their infrastructure and capabilities. But having that web scale capability from the get-go without having to invest in masses of hardware was a huge beneficiary to Dropbox and Netflix. Converse of that was looking back into, for example, 1998, 1999, right? The start of the dot-com boom, where there was no virtualization, there was no cloud, and Sun Microsystems sold a massive amount of systems because companies were going pre-IPO, were building up their environments, were buying lots of web systems, etc., to meet those peak loads. And even if they never met them, they had VC funds to buy all of the equipment, which I think in 2001 or so, you could buy a whole bunch of Sun Microsystems boxes really cheap, right? Once the tech crash came through. Now, the client systems accessing through their mobile devices or web, etc. Right? So it's a client-server-based relationship for a lot of the applications. You've got some functionality sitting on your mobile device or laptop, etc., or web browser, but we develop and provide a lot of the information that comes from the back end. Right? That's where the value comes. That's where the interconnectivity with other users comes from, the ability to share. But we also have the ability through there that localization is really important. So that's a cloud precept, which makes a lot of sense for people. Moving into the application space. Right, so as we've talked about, applications are moving towards microservices. So what that means is that the agile development is part of the process of how we're deploying applications as well. So I'm sure a lot of people have worked in agile deployment type environments of using Kanban boards and sprints, epics, etc. And that ties in closely with how the microservices architecture and application deployment from that works quite well, because we can have small teams working on really small applications. We can have rapid turnaround using the continuous integration, continuous deployment type frameworks. We can utilize whatever programming tools that we want to that make sense for the actual API and components that we're dealing with. We've got decoupled applications from hardware. Right? So whether that's using serverless or containers, Docker, Kubernetes, OpenFaaS, Lambda, Google Cloud Functions. Whatever the case is, there's new ways of deploying applications that make sense for how we manage the applications, but make that application development, the application integration, and the application deployment easier from a developer standpoint. But also mobility. So we should be able to run the applications anywhere. It shouldn't matter where they end up needing to run, but we should be able to push them out to any point. Right? And importantly, the assets or the components that we have outside of the actual applications itself So our test scripts, our integration engines, those cloud modules for how we deploy applications, etc., can all be digital assets, can all be code for how we deploy our applications, which means that once we have all those components sitting in as code, as text, as YAML files or anything else, then we can do an easy text comparison. We can actually check what's changed exactly from release to release, so our change managers know what's going on, and you don't have anyone having to do anything manual to release a new version of a software. Now, from the infrastructure side of things, again, we have the abstracted infrastructure layer. So the application shouldn't need to know what's happening at a server level or a storage level or a network level or anything like that. It should all just work. And that's where we have name-based resolution and service discovery, etc., for how the applications work. But that's all supported by the infrastructure that sits underneath. A large part of my career was working with non-functional requirements. So as an architect, you've got functional requirements, those things that are part of the application that make the application run. So if you're using a billing application, a functional requirement is the ability to pay a bill, for example. Whereas a non-functional requirement is something that you have that the system requires but isn't part of the functioning of the application, such as the ability to back up the system or make sure it's highly available. So non-functional requirements have been a large part of my architectural career, of working out how you deal with these requirements from a business perspective. If they can't lose any data, for example, if you're doing financial transactions and you can have zero data loss because you need to make sure that no transactions get lost at all, otherwise money just ends up floating away into the ether. So how do you deal with all of these things from a modern application perspective? Right? So capacity management, load balancing, backupping, etc. And important, how do we deal with cost management from an infrastructure level if we move to a cloud model utilizing cloud infrastructure? Right? So we want methodologies, we want to have thought put into place for all of these components before we actually move to utilizing them. Because if we don't, we're going to be surprised by one or more. All right. So if you fail to plan, you plan to fail. Right. So one of those, I don't think it was Sun Tzu, but along the same sort of lines. So again, the same as we're looking at with applications, the infrastructure changes should also be written as code. All right. So if we're managing those things as code assets, as digital assets for how we're deploying our applications, it's much more repeatable. It's much clearer how anything changes from release to release and what we're doing to manage the environment overall. From a cloud migration perspective of how things move over time, on the left-hand side of the screen, you've got the legacy IT infrastructure of what we're looking at from the perspective of IT 20 years ago, but is also in large scale in place a fair bit right now as well. And the ability to move over time as we move towards the right, we have more modern applications sitting on the infrastructure perspective. So we move to having the hypervisor sitting above the bare metal. We utilize software-defined infrastructure, so software-defined data centers, software-defined storage, software-defined networking, etc. Right.
Hey, Tim, have you got a pointer on your thingamajig? Oh, I can see your mouse.
Can you?
Yep.
Cool. Yeah. So the first of all, when we're looking at across bare metal systems, we have a hypervisor sitting on above. So saw this come through in for prime time around about 2006, 2007. And over the last probably 8 years or so, we're starting to see the software defined for networking, compute, storage, etc., really move to the fore, and that then enables the ability to abstract your infrastructure. And we're seeing capabilities such as VMware on AWS, that's moving into Google Cloud and Microsoft Azure as well, the same sort of capabilities. And the ability to migrate, do live migrations of application servers without actually shutting anything down from your own data center to one of the cloud environments, right, through the ability of software-defined data centers. Right? So the technology for that is something called HCX, so from a VMware perspective. But sitting above there, we've got capabilities such as the container management, which provides capabilities for how we deploy our container-based applications, and provides capability again for doing those CI/CD pipelines, the ability to update software sitting in the production environment. So some organizations that have active web environments and productive web coders will see multiple releases of their application software through to their websites on a daily basis. So again, 18 months I was looking at from a mainframe perspective. It's looking at a 9 months to a year for AS400 based systems, 6 months for Unix based systems, 3 to 6 months or more for Windows and Linux based systems, for change based in legacy based environments. Right? But as we move to more container-based applications and modern ways of deploying and managing software, we can much more rapidly enact change, and we can put much more of the capability in the hands of the developers and the smart people that are coming up with ideas of how to do things, because we can have things like automated test harnesses and the ability to ensure that anything goes into production is going to actually work. And if there is a problem, we've got things in place to rapidly roll them back as well.
Do you find that the quicker turnarounds for changes affect like the users? Like, do they adapt easily? Do you come up with some issues with that sort of short time space of frustrations?
Well, look, so it comes down again to planning and understanding. All right, so if you just chucked in major changes on a regular basis as cowboys, and lots of organizations have developers, infrastructure people and everything that run as cowboys and will happily shut down systems without thinking about what's coming down the pipe or anything like that, then you will run into problems. But the expectation for any changes that you have in an ongoing basis should not be easily seeable by any of the downstream users. As an example, every time that you connect into the Amazon Web Service console, there's new capabilities that are available because they've been rolled out and deployed into the web front end. Right? So that sort of, there's a lot of thought that goes into the back end of that, that you don't have anything majorly change, you just end up with another button on the screen. And so users, rather than finding that distracting or a problem, find that attractive. It's change which is useful, change which is interesting, change which can actually add to the end user experience, rather than change which a lot of people saw in the past. Because you were only changing once every 6 months, 9 months, 12 months, 18 months, etc., the changes were massive. You'd have to relearn a new version of an application possibly to actually deal with that change. Whereas the changes that we're seeing on a day-to-day basis for these application pipelines are more in line with bug fixes, minor changes, updating things to make them work better, rather than major changes to the interface. Any major change to the interface would be a major update that would involve a large number of people and would probably take the same amount of thought, control, etc., that you would see with one of those legacy applications in the past. For example, if you were doing the So 5 months ago or something like that, Facebook updated their GUI interface. Right? So you had the ability to switch over to that if you wanted to, but there would be a very large team that would have dealt with that. They wouldn't just roll it out to everyone immediately.
Really interesting. Thanks.
Okay. So that's what we're looking at from the broad view. Now, this is one of the assets we have from my organization. Where is it? Here we go. So this is the multi-cloud reference model that my group works on for how you look at deploying applications for within a multi-cloud environment, because that's where we're seeing most organizations move towards. So we saw organizations 3 years or before, they were moving towards signing up with a cloud provider. They were deploying some applications into the cloud. They were migrating some VMs, etc. We're seeing pretty much every organization, or at least enterprise organization that we're dealing with. So this is organizations with more than 5,000 or 10,000 users within their organization, that they're all moving towards a multi-cloud model. Now that might only be in part using Office 365 and email from the Azure network, and using AWS or GCP for a compute platform. But whatever they're doing, most organizations we're seeing moving down a multi-cloud path. Now, what that means is it provides extra complexity, because we not only need to deal with these organizations with their existing data centers, because even though the thought may have been to move out of what they term the data center business of running data centers, if they've moved assets into the cloud, they've still got data centers in all of these large organizations as well. So now they're managing a data center, they're managing a cloud environment, and they're now also managing another or more than one cloud environment in addition to those as well. So what do you do with applications, with components, with interrelation between all of those things on a day-to-day basis when your applications need to talk to each other, they need to share data, you need to have a common data warehousing backend for the amalgamation of data across multiple systems. Right? How do you deal with all of that on a day-to-day basis? And so that's where we end up with this quite complex screen of how all of these different components tie together, and what we look at from a thought process of what we need to plan for each of the components. So this isn't to really delve into any great detail, because it's we could be here for hours, but just to show you some of the thoughts that go into corporate enterprise level cloud deployments, etc.
It's quite something.
It's certainly something, yeah. All right, so now another question.
Yes. I should have said all of them at the same time as well. Which type of cloud technology are you most interested in? No, we got the most. That's all right. You can make a choice, damn you. All righty. Cloud platform.
Like these ones where it's a close race. Oh no, cloud platform's really ahead. It might have been the really cool graphic that I just step up on the screen, really inducing people to create massively complex Visio diagrams.
I like infrastructure as code personally. Like I'm super interested in what you can do. We've got a couple of good short courses out there.
Yeah, well, that's because I'm quite interested in the governance side of IT, like one of the driest interesting sides of it. But how you deal with governance from making decisions from a corporate IT side of things, and managing that. So the infrastructure as code it really ties in closely to what you're looking at from that governance view of IT systems.
Okay. We'll have to look at some good resources for cloud platform interested people, given so many are. We'll try and find you some good readings and stuff.
No, this is good. All right. Well, it's nice to have a clear winner.
Yeah.
It's only 46%, so as soon as me and a lot of other people were looking at the US election, it'll go to a runoff election January or something like that, I think. But,
Yeah, welcome to Georgia. Oh dear.
Yeah.
All righty, we'll stop that share. Thanks.
Cool.
We'll focus on maybe some cloud platform resources through the week.
Oh, that's good. All right, now to jump into a demo. Now, we're talking about infrastructure as code, and what we'll look at here is something, I'll just get that down a little bit so that I can, I've got a text bar at the top of the screen. So one of the things that this is just my subject resources for subject I'm running at the moment, which is containers and virtualization. So basically doing a deep dive into Docker technology of how you manage Docker and deal with it, etc. And so part of that, as far as infrastructure as code, if you're interested in that sort of things, then you'd very much have a Git account. So the Git account is a repository storage for our digital assets that we have for a particular project. So this is my resource repository for what I'm doing for the students at the moment and with the students for the ITE 532 subject. And it has some interesting components. So one of the things that we look at is the ability to go and build a virtual machine based upon predefined settings. So with this, I've got settings to bring up a really cheap virtual machine, and I've got all of the settings in place for how I want it to run. It's only going to cost me a few cents to get up and running. So if I come across to Google Cloud Platform, sorry, I didn't copy and paste it. I can, yeah, it is not working right now. Ah, that's right. I lost my connection to the shell. That'll reload. So while that's reloading, so this is looking at the Google Cloud Platform console. So anyone that's interested in the cloud technology, I very much recommend that you have set up a Google Cloud, Azure, or AWS, or all three, because you can get free tier access. You can utilize resources across them. So if we come across here now, so I'll just authorize the creation of that. We're now going through and creating a virtual machine that'll be up and running. The other thing that it'll do is it will go through and pull one of my other assets, which is in the site. So automation and making sure that everything works really well is having well-known assets and uses to make sure everything runs correctly. So on build, it'll go through and run this script as well, which will install Docker, plus some other tools and bits and pieces, plus access to the repositories that I use so that I can upload anything to Git, and it'll automatically be available on my new VM that I built out of here as well. So we can see on the Google Cloud Platform, if I refresh here, we should see instance 1 up and running. So all good. Now, I've got one already up and running here, but if we have a look at this, sorry, I will just clear out the what I've got up and running at the moment. I forgot to clear this just before I started. My apologies.
Oh, good. It'll give me time to catch up.
Yeah. So what we've got here is one of my Google Cloud VMs. So it's running Ubuntu Linux, and it's available for me to access whenever I want. Super cheap, available, etc. But This allows me to go through and do things like run a Docker instance. What I'm doing is I'm saying run a Docker environment. The -D means it's running as a daemon, which means it'll stay up and running. I want it to map port 80 to port 80 so that it'll be available on the host. And it's now up and running. If we come back over to the Google Cloud platform, so instance 4 is the one that I'm running on. See over here, I've got a link to an external IP address on there. Now, this won't work to start with because by default that tries to connect to an SSL connection, and I've just opened up port 80. So anyone at home can play along. You can put in the same IP address and hit my same web server. So try not to hack me too hard, but anyone else can also see exactly what I'm seeing because it's live on the internet right now with the way that it's deployed. So you can see we've now got an NGINX up and running, and it's available. So we've done that really quickly utilizing containers. We can also come back to the container. So we can do docker exec interactive. I need to work out what the name of the container is. All right, so what we're doing here is we're telling it to run a command inside the Docker container that we've created. And we're telling it to run bash, which is just the command interpreter. Now, if we go through and move to where the directory is that contains the HTML files, we can see we've got index.html. We can have a look what's inside there, and this is the file that we were just looking at right then. Right, so just to confirm, welcome to NGINX, and that's exactly what we're seeing in this file here. Now we can also change that. So we can go through and overwrite the file with a new command. And immediately, because we're inside the file, we're updating the information, we can go through and update that, and we see the text that we just put in there. And again, we can change it again if we want to. Right. Immediate change, immediate update, and we can see what's occurred. Now, so what we see here is how we manage our virtual machine sitting within the environment. What we also have within the Google Cloud platform is the ability to view a whole bunch of other resources, capabilities, applications, etc. within the environment. So a whole bunch of things that we can deploy across the board. And similarly, we have the same with, I've got a Microsoft Azure account where I can do the same sort of things. It's a different view, but most of the things that you do within Microsoft Azure are mostly the same as what we do within Google Cloud, which again are mostly the same as what we do within Amazon. All right. So for me, the major areas of real usage for the different platforms that differentiate them from each other, if you're looking for a standard capability, they all do pretty much the same thing. Where I see take up of the platforms, AWS was kind of first. So we see a lot of cloud native applications getting built for the platform. We see a lot of migration of systems, and they've got the biggest engine from a professional services and sales environment to really push their capabilities into the marketplace. So they're a massive juggernaut in the space of compute capability, etc. From an Azure perspective, we say that if you're a Microsoft shop, if you're already utilizing a bunch of SQL Server capabilities, if you're using Office 365, if you've already got licenses in play with them, and you're going down that path and you have a development backend in particular that uses Visual Studio, then this really fits in well with what your corporate's looking for. And finally, Google Cloud Platform. Again, it's just as capable as the other ones, but where I'm seeing it get used heavily, I'm working with a large retailer at the moment, and they utilize the Google Cloud Platform from an analytics perspective. So the analytics platform for them is very strong. The development tools, in particular for cloud native, open source, etc., are excellent. And the integration with those back-end capabilities and code-based services are very strong.
I think we've got our short course, Tim, a demo from all three, like in depth, when to use it. That'd be fun.
Excellent. But yeah, that's the end of the demo. So we're then looking at the future of cloud. So where are we heading? So what we're looking at is, so edge computing and access is a big one that's coming up. So we've got the ability to have applications from a cloud perspective, so AWS, Azure, etc., are deploying resources in edge locations, which can be public spaces, it can be in a large part telco organizations. So the ability to have very low latency links for application providers that are made available on the edge, what we term the network edge. The other big push is for IoT and 5G. So these two go really much hand in hand, because I've seen a few things around 5G on the news over a little while. I work with a bunch of the telcos that are rolling out 5G infrastructure. So network function virtualization and container function virtualization, a large part of what organizations such as Optus and Telstra are doing with their 5G components. So what we had with VMware in 2010 for the virtualization of applications, we're seeing that with the components that run the 5G applications now in the field. So lots of the edge sites and the towers, etc., will have servers sitting underneath with virtualized systems. But that ties in with IoT because 5G can be very low power. So if we have a device sitting out in the field, which is running off the battery, we want to be able to not change that battery for 6 months, a year, or something like that. And if we're using 4G or 3G network connectivity, that won't work, right? So we need to have that connection up and running for a significant amount of time. We can't do simple wake up, send a packet, shut back down again with 4G, etc. 5G is made to really save on power and make capable a lot of smart city type capabilities. So smart street lights, lights in parks, analytics on all of the use of that sort of space through sensors, etc., and the ability to have other functions available in buildings and public spaces. Expect to see as well further moves to software as a service, in particular with API links. So the ability for organizations to deploy their software as a software package that you don't need to host yourself, but organizations still need to have those back-end links into the applications from a data warehousing perspective or to integrate their other applications. So we'll see a large growth in API links into SaaS platforms. Security and privacy are always front of mind for at least a certain subset of people, and especially with the push that we're seeing with things like Facebook, Twitter, etc., from a social engagement perspective, that the expectation is that we have something which is secure and private by default. Ubiquitous economic access. What I mean by this, and why I've got the picture of the rocket on the side, is through capabilities such as the SpaceX Starlink capability or the internet capability that Amazon will be launching in the next few years when they have their Blue Origin up and running and ability to release satellites. So we're expecting to see 10 to 20,000 satellites from SpaceX and probably a similar number from Amazon reach low Earth orbit to cover the globe in what should be ubiquitous internet access and therefore ubiquitous access to computing resources. And so that should lead to a leapfrogging of technical capabilities from a lot of developing nations. So countries that haven't invested in fibre to the house, in potentially an electrical grid, in having educational resources available for everyone, will suddenly have internet capabilities through solar panels on the roof and a little dish that are available to an entire village. And so what I'm really excited to see is the democratization of education and capability across the board to developing nations, to poor people, to where there's gender issues, etc. And that capability is made available to everyone. So a nirvana type view, it might be a little naive, but it's certainly what I would hope to see from this type of change moving into the future.
Interesting. Do you see that? Do you see that change sort of being driven by, you know, those big three hyperscaler types?
Well, I see that from that perspective, the cost of resources will continue to go down. So just as an example, I'll just pull up the information on here. If I come through to my billing report, people can see what I spend on my VMs. All right, so this is running VMs when I need them for my course, to do demonstrations, to do labs, testing, etc. So I'm running at 36 cents for the month or something like that for running compute resources. And so having the capability to run at those sort of costs is quite advantageous. I've got obviously my own compute resources where I could do more if I needed to, but the link with having highly powerful, cheap computer devices that can sit in someone's hand, the coupling with that of cheap augmented reality or virtual reality for being able to do large-scale views of environments and things like that, and the low cost of additional compute resources and lots of analytics and other capabilities sitting in the back end from the likes of the big three, so AWS, Azure, and Google, mean that entire data centers are at the hands of people who have not grown up with access to anything. And so I see those cloud providers as definitely being part of it, but the first step in that link is getting that network link to the remote areas and then moving on from there.
Cool.
And just as a note here, we've got some additional resources that are available from for IT Masters. Did you want to speak to this, Guy or Hannah?
Yeah, just similar to last week. At the end of Matt's session, you know, there's a bunch of free short courses that are sort of tangentially related or very directly related to this session. You know, and for those of you that are interested in, I guess, you know, taking cloud computing as to be like the specialization that you're interested in if you're going for a career transition, sort of we'll try and provide as many resources as possible to help build that platform, I guess. I guess the most valuable, you know, extra resources, I think, in the context of this short course will just be the discussion forums. We'll get a prompt for you. We've got a couple of, you know, start a couple of discussions and then ask for your sorts of insights and I guess see where you all land on sort of contentious issues and yeah, see what we can come up with and build it together. So I'll put those links up in the short course in days to come, along with all of the other resources, the recording and the quiz and the forum stuff. And we'll look at some cloud platform resources specifically, given so many of you are interested in it.
Cool.
Thanks, Tim.
All right, which brings us through to question time.
Yes, and one of the first ones I'll go through is Sam's, who's, you know, a little bit, as Sam says, drowning in indecipherable acronyms. We'll get a glossary for each week going in the forums as well. If anyone has one on hand, chuck it in the chat now so people can go to it really good, like right now. That'd be really good. So we'll deal with that one. Guillermo asks whether you have an opinion on the newly launched Google IT Professional Certificate and I guess Google certification generally.
Yeah, well, the Google Certified Professional Architect is the last certification I did. I did that like 2 months ago or something like that. So obviously I have some weight to the Google certification piece, but I think that any of those levels of education can be valuable, but it also depends upon what it is that you're using it for. So if you're looking for a job and you've got some existing experience and you just want to round things out, it can be perfect if you're, in particular, if you're going for a job which is in that Google Cloud space. But in the general sense, people will look quite favorably upon people who are certified in technologies, even if there's ones that they're intrinsically tied to, just as it used to be that people would look for someone with a degree, even if it wasn't in the area that they were looking at. Just the get up and go of someone to do learning outside of their normal day-to-day work and go through the process of learning it, going through the certification process is seen as valuable. For me personally, I like the process of certification because it gives me, like I'm quite a goal-orientated person, but I'm also reasonably lazy. So I need to have a hard stop date. So when I've decided to get going on learning something, I book my exam to make sure I've got a hard stop of when I need to learn things by. I'll just end up continue flapping around for months.
Very good. And that's honestly one of the advantages of postgrad study as well, or just, you know, tertiary study.
Yes, yeah, you've got timelines.
Put a framework around you. Yeah, so are there any sort of, I guess, first port of call certifications for people interested in building cloud capabilities, like, for example, a Network Plus for people interested in networking?
Yeah, so it really comes down to going in with a plan is my suggestion of getting advice, if you can, from people in the industry. As I mentioned, I'm more than happy to have people connect to me on LinkedIn and to field questions if anyone wants some career certification or education advice. More than happy to answer questions. But you need to have a plan as to what your course of action is, right? And going through those initial certifications may be worthwhile, but you want to be going into those because they're not cheap. They're not, so you don't want to just be going scattergun at various ones. You want to go in with a plan of the type of role that you can realistically get based upon your current experience, plus the certification sitting on top. And my view for certification is using it as an education, planning, and springboard for the next role that you want to move into or to extend your career in the space that you're currently in. So you don't want to overreach. So if you're not currently in the IT industry, going through and doing, so for example, the AWS Professional Architect exam, it's going to be seen as useful for getting a role, but not as useful as probably a lower down certification that might be closer to the type of role that you would have as an entry-level role.
Yeah, super good point. Like, everyone's in a different position as to where they're going, where they're coming from, and where they want to go to. And that, I guess that's one of the
just like anything though, you need to plan for it and you need to get advice from various people and hopefully people that know areas more than you. So as I said, I've been in the industry for 30 years, but I still look to advice from my peers, from managers, from other people that I work with and people that I admire, because I'm still looking for what I can do, what I can change, how I can be a better version of me.
Yeah, cool. And I guess for those interested in tertiary study, where we come in is helping you sort of work out that plan together, give us some goals, give us where you'd like to get to, and we can help.
Exactly. Yeah, and also the ability to network with like-minded people that are studying at the same time. So that can't be overstated either. The work that you have in having a group of peers that you're working with towards a common goal, and the ability to make some virtual friendships over your learning path.
Beauty. Let's go right up to the top of the questions then. AN asks, for cloud native a designation, what's the failover time of a typical primary server to a secondary server?
So if you're doing cloud native, you wouldn't be looking at a server failover. So you would have a mesh infrastructure probably of utilizing microservices or something like that that would be inherently capable of failing over, so that if you had a individual component fail, you would have a load balancer that would automatically move clients to one of the other servers and start up a new one. So you wouldn't have a failover in a traditional sense. You would have a service stop and usually impact only a very small number of people, because you would spread that load out over multiple servers and connections. Sometimes for shopping carts and things like that, for complex websites, you can end up with a single container per user. So if you have a container or microservices system that stops, it's only impacting that user, and it can restart then for them to get started where they were left off.
Wow. Alrighty, thank you, Ian. Anonymous question, do the problems accessing MyGov services such as Centrelink have anything to do with how cloud-ready MyGov is?
Yeah, I don't know exactly what the infrastructure sitting in the background of MyGov is. I know that a lot of the infrastructure in the past has been built off the IBM cloud platform. And so as an example, the Australian government census site, we had the famous crash of the census going back a few years ago. And the reason that it actually crashed, like, there was a large talk of it being a hack event that caused the whole thing to break. But it was actually a Telstra line down to Canberra that caused the first outage. But it garnered so much press at the time that it went out, that it went offline, and as soon as it came back online, it was then a target for hackers doing distributed denial of service attacks against the infrastructure from that point onwards. So they had a mostly capable environment, but they didn't have it set up to enable that type of security load. But also they didn't have a proper web scale set up for that. So I wouldn't be surprised if MyGov was at a similar sort of level to what they had for that census type implementation of not being proper web scale.
Interesting. And do you think that was just a budget decision?
Well, yeah, you've got to deal with, so government's an interesting beast, because you have a whole bunch of compliance work that needs to be done for any applications and things like that. You've got a tendering process for how things roll out, and you can only select someone that meets the compliance levels that you've put in place, and you often need to select the lowest bidder for any work that's been put through. And so anyone that's putting in a bid is working out some way that they're going to make some money. And I would hazard it's more to do with some of those outside realities necessarily than the architecture and componentry which is put in sight from the professionals that are designing the space in the first place. I mean, certainly the architects working at MyGov aren't completely blameless necessarily. I'm not sure, but certainly there's externalities that that can tie your hands in that sort of situation.
Thank you. Gavin asks, what's a hyperscaler?
So hyperscaler is just what we term the ability to, as the name implies, scale at a hyper level. So when we're talking about cloud scale or web scale, is the ability to rapidly grow and have massive compute network and other resources sitting behind you. So there's been other cloud providers for a long period of time, a lot of them with a lot of the same sort of capabilities. So I used to work for one called VirtuStream, which was Dell's cloud arm that did mostly SAP hosting. There's other ones from Dimension Data and Optus, Telstra have had cloud environments in the past, but they've mostly been around hosting discrete systems, not in having the API capability to do the automatic flex and scale, and also having the systems in the back end to massively scale environments overall. You more would have your corporate components sitting within those cloud providers doing regular corporate application type things rather than more cloud native scaling functions.
Thanks a lot. Anonymous attendee has asked what other free courses are available. Hannah, could you please chuck a link to the free short courses page where you can see a full list of them in the chat, because I can't do links in the Q&A section, which is a bugger. Guillermo asks about that repository you were showing for ITE 532. Is that repository private or can anyone have access to it? I'm pretty sure.
Anyone can access that. So if you have a look at the slides, there's a link down the bottom of that page to a link to the repository. So you're more than welcome to have a look at that.
Great, thanks a lot. Alrighty, Gabriel asks why it's so hard to get a traineeship. That is a complex answer that we're looking for. But I'm just using it as a little plug for the bonus webinar I've been talking about. We're going to put together a session about some internships that we're introducing. So maybe not necessarily a traineeship, but hopefully something that'll help you get a foot in the door for those that are interested in postgrad study and interested in doing an internship as part of that. Yeah, there's a bunch of courses. Anonymous attendee who asks any course available on server management, networking, cloud, security, which we'll talk a lot about next week as well, and all of the other areas we teach in. Prudent asks, I want to know whether the cloud site space is expended. I suppose are there limits, and where do you see limits coming, if any?
Yeah, so there was a concern going back into the 1990s that we'd run out of IP addresses because there was a limited resource pool of IP addresses that were available around the world, and the view was that we would eventually run out. Now, with the abstraction of networking, networks, and the ability for organizations to use native address translation as an example, that basically evaporated as a problem at the same time as they implemented the IP version 6 standard. So one of the big reasons that IP version 6 hasn't kicked off as something that everyone uses on a day-to-day basis is because the reason it all came about was the view that IP version 4 would die a death by like 2010, and IP version 6 was absolutely needed. So IP6 is certainly out there. It's used in backbone systems, etc. And it's an almost inexhaustible supply of networking resources. From a compute perspective for cloud, we're seeing larger scale systems at lower power and higher capability come through. For anyone that's looked up Moore's law before, the view that compute power will double every 18 months or so has stayed true since, I think it was 1958 it was first coined. But that at some point is going to stop as well. So we're going to stop being able to increase compute power over time, but that doesn't mean that we'll necessarily run out of cloud or compute resources from a networking and processing perspective, because we'll have enough still.
And then I keep hearing about this thing called quantum computing, which I have no idea about.
Yeah, quantum computing is completely separate to what we do on a day-to-day basis. So it's extremely specialized for doing some very special functions that are impossible or would take the length of the universe in time to actually complete if you were to do with a traditional computer.
The future is coming. Habib asks, doesn't the hyperscaling come as part of a package for a cloud service?
So hyperscaling is just a term. It's not a release feature or anything like that. So all it's saying is a large scale cloud provider is a hyperscaler. So what we're talking about when we say that is really the big three. So AWS, Azure, Google Cloud Platform, and also Alibaba's in there as well.
Beauty. And that leads into Nicholas's question. And I'll stop taking questions now because we've run you very long anyway. And thanks so much for your time, Tim. It's been really nice. Nicholas is about to go for the AWS Solutions Architect Associate Certification. Already got this cloud practitioner. Any tips for studying and the aspects that should be focused on? Nicholas, we have a short course on that exact thing. I'll just chuck the link in the chat. It was run by, Scott Farrell. So have a look at that. That's a 4-week, basically a short course to try and get you primed for your certification. It's not replacement for study, but it should really help you, I guess, make that plan and work towards it more effectively. And I guess the same could be true of people asking about Google certifications. You can find all sorts of resources online. It'll talk more about the ways in which things can be scaled. So go and have a look at that if you're keen on this sort of stuff.
Yeah, my advice around looking at any of those certifications is find some material that works for you, because everyone learns differently. So it's up to you to know how you absorb information the best, whether that's through videos, whether it's through hands-on, through working in a team, etc. So you need to know that. But once you've got that bare knowledge and you work through as much as possible, one of the things that I always do is find some practice exams. I don't do timed exams with those. What I'll do is I'll work through the entire question set, and the questions that I don't immediately know the answer to and why all of the other questions are wrong, I will go and research why I don't know a particular answer, even if it's one of the wrong answers. So if it's something was asking about elastic beanstalk, for example, in an AWS exam, and I didn't understand what it meant by that, then I would go through and read the manual pages for that until the question made sense and I was able to answer the question clearly. So that would be my advice.
Thanks. Hope that helps, Nicholas. Good luck. Let us know how you go. Alrighty. Well, I guess that's the lot of it. Thanks so much for the questions, folks. What's for dinner from Flappy Bird? Yeah, I think pizza for me. Thank you, Tim, so much. That was really nice. Thank you indeed for the triumphant return of Dilbert to the short course slide decks. We had one last year that started every week with a Dilbert comic, so that's really nice. So yeah, thanks Hannah for sticking around and for looking after the chat. Thanks everyone for sticking around, and hope you're having fun. Chucks all your questions in the forum if we haven't got to them. We have to stop at some point. Also, I'm going to chuck in the forums a thread about what I've forgotten, because I promise a lot on this short course and I try and get to it. So if I do forget, just give me a nice swift kick up the bum. and thank you for your patience. It's a it's a bit of a love job. Tim, I'll throw it to you. Thanks so much, man. Pleasure to meet you. You can have a sign off.
Excellent. Much appreciated, everyone. And yeah, just remember, keep learning.